the area of a sector using radians. The area of this circle is pi r squared. The area of this sector will be pi r squared times a certain fraction, and that fraction will be theta, which will be in degrees for the time being, so theta divided by 360. So we need to multiply by this fraction to get the area of the shaded sector. 360 is 2 times 180. We can rearrange as follows, and we know that if theta is in degrees and we multiply by pi over 180, we get the angle in radians. So we get this formula, which will give you the area of a sector where theta is measured in radians and r is the radius. In this example, the angle is given in degrees, so to use the formula half r squared theta, we need to convert the angle into radians, so 45 times pi divided by 180. So the angle is now a quarter pi. So the exact area of the minor sector here is 25 over 2 times pi. To work out the area of the major sector, we need the angle here in radians. So in a circle, the angle is 2 pi radians, so we have to subtract a quarter pi for this part, and then we can work out the angle for the major sector, which is this, and the final answer, the exact area. And just to verify, the area of the minor sector plus the area of the major sector add up to the area of the circle. So I've added those together and I get 100 pi. The area of the circle, pi r squared, gives the exact same answer. The area of a triangle, half AB sine C. Now in this formula, A and B here are both equal to the radius of the circle. So we can replace the A and B with r, like this, and that's obviously r squared. So the area of the triangle is given by half r squared sine theta. Now the angle theta, if it's given in degrees, your calculator needs to be in degrees mode. If the angle theta is given in radians, your calculator needs to be in radians mode, because you're using a trig function on the calculator, so the correct measurement or mode of measure for your angles is vital. When using this formula, the mode on the calculator, whether it's using degrees or radians, does not matter, because you're not using any trig functions. In the next example, we look at the area of the segment, so the area of this region. So the shaded area here is the segment, this is the sector, and this is a triangle, and if we subtract the triangle from the sector, we're left with the segment, like this. So some algebra, we know the formula for the area for sector, we know the formula for the area of the triangle, and this formula here for the sector is in radians, so we should use angle theta in radians right throughout, and your calculator should be in radians mode too. Either the formula can be left like this, so you've got the sector and the triangle separate, or this one can be memorized, where the half r squared theta has been factorized out, because you can see there's a half r squared theta here and here, so it's just been factorized out. But the theta must be in radians, and your calculator needs to be in radians mode because you're using a trig function. Example 5. What's the angle? Now we can see from the triangle, 3 of the sides are given. It's not a right angle triangle, so we're not going to attempt SOHCAHTOA. We can use the cosine rule for this. The theta and the opposite side tend to opposite each other, so they will be in the formula as well here. So I've rearranged to work out the cosine ratio. That's what this fraction here is giving, the cosine ratio. And if you do arc cos or cos inverse on the calculator of this cosine ratio, you get the angle. And if your calculator is in radians mode, you will conveniently get the angle in radians, which is what we're after. So we can calculate the area of the sector, where theta was in radians. We can calculate the area of the triangle, half AB sine C, where A and B are both the radius, so half R squared sine theta. And then if we subtract the area of the triangle from the area of the sector, we get the area of the segment. Or we can use the formula that combines them both together in one convenient form. Same final answer. For practice, try these questions.